afternoon, everybody. My name is Jay Franetovich. I am an application specialist here at Middle Atlantic Products. I'm going to take you through a presentation called Not Just a Pretty Rack. It talks about things like doing things as a system. So we're going to jump right into it and we'll get through. So description, and of course, what we're going to do is we're going to talk about a few different things that we look as a system, whether it be thermal, cable management, and structural. So that's kind of what we're going to go through today. And here are some of the things that we're going to talk about as far as a system approach goes. Basically, we got best practices. We'll touch on that. Rack structural, cable management, and thermal, like I said. So one of the things that you guys do, you spend a lot of time building a great system, a lot of parts and pieces, you bring it all together, looking at all the ways that you need to make your customer happy in order to have this system that ends up being one big piece. So part of that is getting it all into the rack, and we look at it the same way. We're going to go through some of the stuff. So we know that the system that you have designed actually works and it's more reliable and things like that. So basically when you get done with your system, you basically just don't want to put it in anywhere. So obviously a hot little grass hut's not going to help you out here. So we're going to start with some rack facts. Rack mounting kind of started back when they started railroads. They needed a standard to do all the different, as they were building the railroad, so a kind of rack mount kind of started back then. It got, 1965 EIA made it a standard. Now that falls under TIA and ANSI. EIA is no longer. However, the standards still stay the same. You got your rack spaces. Some of the stuff you may know, but other stuff we're going to just touch on real quick. So you got your rack space, 1 3/4 inch, 19 inch. Common screws threads. So what you guys see a lot of is the 1032, the 1224 and the 6 millimeter on the structured side or on the data side, and the 5 millimeter is international. You got your different panel widths, which you got 19, 23, and 24. 19 inch is what you guys are going to see mostly, you see in the AV world. 23 on the data side and 24 some old telco stuff and some switching stations and things like that may come across. And then we're looking at a lot of the stuff out there. In the weight capacities, we're probably looking at, you know, a good rule of thumb is you figure about 20 pounds per rack space, which gives you on a 44 space about 900 pounds. So looking at the weight of the racks that you're going to need, not knowing a lot about the equipment that's going in there, it gives you a good idea of what it's going to be. So best practices, one of the things that you get out of best practices is you get increased system reliability. Basically what we're talking about here is cooling and cable management and things like that. These are some of the stuff we're going to touch on a little more in depth. So you got ease of integration, reduced time spent in the site, could be stuff that you can load in the shop, bring out to the job site, and simplified servicing. So when you have to go back out there, it's easy to find what there may be a problem. You can easily find, trace out a wire or something like that. And then aesthetics being a big part of it. After you leave that job and that rack looks really nice, you're going to get that call back knowing that you spent some time and it looks good. So basically what we're going to do is we're going to start with rack structural. What this is basically some of the things that we're going to touch on here is beginning at the bottom of the rack. We'll talk about why. Rear support is pretty important. Maintaining low center of gravity for safety or if you're pushing the racks around on casters. Ergonomics, and as well as cantilever effect about the equipment that's not rear mounted and things like that. So beginning at the bottom, one of the things we like to talk about that is if you don't always have two guys to do that heavy stuff to put in the rack. If you have the ability to lay it down on its back, what you can do is drop your gear in, kind of lay it into place, knowing, okay, here's what I want. Even if you just start with the bottom couple of pieces that are heavy, drop them in. At that point, that becomes your building block. So now you don't have to hold the piece of equipment up while you're trying to get 4 rack screws in. So that's one of the benefits of doing it at the bottom. When you're distributing the weight, one of the things you talk about is 2/3 of the weight should be at the bottom third of the rack. That stops a lot of that from tipping and things like that, and that's how a lot of stuff is tested as well. So for weight and stuff like that, it's tested at that standard. Space creep. One of the things that happens is EIA standards got a very tight tolerance of where the holes are. every panel, piece of gear, they all have big ob-rounds on them. So what happens is if you're justified too low or justified too high when you put the rack screw in, when you get to the top, even though you may supposedly have 2 rack spaces, it may be short because of all that little tolerance that built up at the top of the rack. You're gonna get to the top and going, oh, this doesn't fit. And what has to happen, you gotta start from the first one all the way bottom. You loosen everything and hopefully you could drop it down and get it in there. So that's one of the nice things too about doing it at the bottom or watching that space creep. You can watch, a lot of the manufacturers have hash marks as well as numbers on the rail. You'll see if it starts to go over the hash mark, you may run into a problem further up into the rack. And then again, we talked about, if you're only one guy there and trying to get a heavy piece, it's easier to drop in, down, than try to hold up and do that. So rear support's a pretty important one. Not all the manufacturers do have rear support on equipment that may need rear support. You see it a lot of this with a lot of switches. They're front mounted and put them in the rack and they kind of start to flex down below. Well, you don't want that, especially on digital equipment that has some sort of board or a connection soldered in it. The more flex you're going to get out of that piece of gear is a good possibility that piece of gear something might let loose inside. So rear support's important. A couple things to think about is 10 pounds per rack space. So if I got a 2 rack space unit and it's about 20 pounds, that should be okay, but you got to look at where the center of gravity is. Some equipment has more of the weight towards the back, so that's going to bring the equipment back and make it want to dive down. Or as well as your height, 2.5 times the rack height. You look at something like that. You may have a 4-space piece, but it could stick out pretty far back and doesn't have rear support. There are a decent amount of ones that do come with rear support, so try to use them whenever it's available. And what it allows you to do is, some of them have the Z-rail, mount to the side, other ones are mount just like they would in the front. If you don't have the ability to have something on the back of the unit, you could do some sort of lace bar or just something on the rear rail to actually hold it up and take that stress off the front rail. We talked about this a little bit. Key thing to just follow is 50% of the weight, the bottom third, 25, then 25. Again, we test to standards that way. If it's racks on casters, a lot of times you want to push up high. So that avoids that from doing that. And we have to actually, part of the test is a tip 10 degree with that weight so that you can make sure that's not going to tip over and hurt anybody. Ergonomics is a couple things you got to look at here. One for the client. So if there's something that he's always touching or needs to turn on and off, you don't want to put that all the way at the bottom of the rack. Just like displays. If there's something to display, you're not going to put it all the way top or all the way bottom. So when you do your rack layouts, it's something you want to consider. And then for the technician as well, how often does he interact with it in the back? Or you don't want to put something that he has to get a ladder every time in the top of the rack to play with. You want to try to put that in there so he can easily interact with that. So a couple of things to think about when you're laying your racks out. Talked about cantilever effect a little bit. I've seen this a lot out in the field. What I think is that you're saving time. I'm only putting 2 rack screws instead of 4, so I caddy corner them like this. Well, what that does is it twists the unit. So definitely not a good way to do it here either, because you can see when your weight is actually pulling, that's going to bend the face or the ear of the component. If you are laying out a rack and you want to put 2 rack screws in for real quick, make sure everything looks good, and then go back, what you would do is you would do them both at the bottom, come back around and make sure you put all 4 rack screws in there. It's just, there's 4 screw holes there for a reason. Use them because you don't want any of the flex or anything like that to happen. So I'm going to jump into cable management now. So here's a few things that we're going to talk about for cable management. Benefits of cable management, things to be aware of, cable entry. So once we know what the cable entry is coming in from above or below, then we're going to have vertical and horizontal cabling that we need to do, and then just some standards you can reference to if you come into any questions. So the benefits we kind of talked a little bit about. Support cable. Basically takes the strain off the connection. Segregation of cables, it helps with finding things as well as having a power and a signal cord too close to each other. You don't want to have that. So the vertical lace gives you a good way to segregate the cables. Leaves it nice and neat as well, and allows a lot of the stuff that you'll see out there, the vertical and horizontal, are using slots now instead of holes. That's for Velcro, trying to get away from the wire ties as you guys start to use more and more category cable that you shouldn't be using the wire ties for over tightening purposes. So that's that, and then basically, a well-dressed rack is a lot easier to work on, leaves a great impression for you and your company to your end user or your customer instead of having something like this. So a couple things to be aware of. We're going to go through in each one. You got bend radius, pull force, over tightening, as well as cable twists. So bend radius, again, a lot of this stuff you want to check with the manufacturer of the cable. However, these are rule of thumb. If you don't have that available, any of the category cables, what you want to do is if it's 4 times the diameter. So you check the diameter of the cable, 4 times that would give you a good radius that you're not going to have an issue with. Pull force. Pull force can come in 2 different ways. There's the way of when you're doing pre-wire. If you pull on a cable, it's about 25 pounds of force. So you got a bundle of cables. If you feel like you're really putting your weight into it, you should probably stop and check and see what's going on. Don't continue to do that. There's a lot of things that can happen to the cable by doing that. And then the other part is when you lay the cables out and then up, whether it be in the ceiling or however you're laying it out, and when they drop down, just making sure that you're not dropping on a sharp angle, because the weight of the cable itself can cause that problem, make a 90-degree angle. And then that pull force would be putting all onto the corner of where the cables are coming down. Lots of things out there that'll help you through that. There's cable pulley systems that you can put up temporary when you're running big, long runs of cable. You use big bundles from one side to the other, and then once you're done, them pulleys come off. Gives you a nice, easy pull, and then you can put them right back on the cable ladder or however else you're hooking the cables up to. So that's the 2 ways, and then the distance of supporting the cable. So as you can see, you'll see lots of, I want to see a lot of belly in the cable like that, because that'll actually putting stress on both ends of where it starts to dive down. So over tightening. So again, looking for that using a Velcro. So basically on all your category cables, you got your cable, you got your pairs inside. You also have a lot of air in here that's meant to help the performance of the cable. So picture it as a garden hose. So if I got a garden hose that's nice and straight, my water's flowing really good. I take that garden hose and I kink it. What happens? The water starts to slow out. That's basically what happens, just like your information going across the cable. Your cable is going good, you squeeze it, information is going to drop down. It's not going to check the spec, and it'll just lower the performance of the cable. Again, a lot of this stuff is you can check with the manufacturer. This is all stuff that they put in either on a box or on the website. I'm sure you've seen a couple of these out in the field, pulling the cables, and all of a sudden, hey, what happened? That probably usually happens a lot of times when you're pulling the cable. So as you're doing your pre-wire, you may feel a little tug. It could also be with your temperature. A lot of times you may be doing a pre-wire in a building that's not air conditioned or heated, so you could be in a 30-degree room pulling cable. That's going to be some issues too. That's stated as well, what the temperature is for the best time to do with the cables. And then to avoid kinks like that. So you do bundles, you can always you keep them nice and tight. You should avoid by having, shouldn't end up with any trouble like that. Again, if you feel a tug or a snag, check it out. There's probably usually a problem somewhere. So now you got your cable pre-run. Now it comes time to bring it into the rack. Basically, there's 2 ways you could look at it and bring it into the rack or the enclosure or whatever you're using. You can come in through the bottom, or you can go in through the top. A good thing to know with a lot of the enclosures that are out there, and a good thing to look for, is a wide open top or a wide open bottom. A lot of times you may not know exactly how that's going to come in. So if you had both open top and open bottom, you'll be able to handle that situation when you get out to the job. And then as well as, sometimes you may need a closed bottom. You can, fill it in or with options to close the bottom if you got your cables coming into the top or vice versa. So, but basically it just covers you in both ways. And then basically at that point, now you got your cables in your rack. Now it comes time to dressing, and your first thing is going to be vertical. You're going to dress vertically. Whether you're coming up from the bottom, you're coming down from the top, you're going to dress it vertically and kind of branch it out to all your equipment. So basically, there's a ton of different verticals that are out there. You see ones with holes. Again, try to go with the ones with either a slot or some sort of thing for Velcro. You want to keep the Velcro in mind. You got trays. These are nice because you could basically make turns at any point, more like a lattice. So again, choose a style based on the cable that you're using. You know, if you got a lot of power cords, you could do something like this. Wire ties are not going to hurt your power cords as much as they're going to hurt a category cable. So, and then the benefits of it, again, supporting the cables, pull force, bend radiuses, and things like that, and the segregation cable we talked a little bit about, as well as allows for the hook and loop fastener as well. So now I got my rack all vertically. Now we're going to do some horizontal cabling. Lots of different offset lacer bars out there, different types. There's round, angled, square. Basically, it's something that, you know, as you guys start using it, you'll pick one, and that's the one you're going to work with. You know, and not everybody uses the same one, obviously. So you could see we sell. There's a bunch of different offsets, and one of the reasons why the manufacturers do different offsets is a lot of this is done off your rear rack rail. So obviously, you could put your rear rack rail in a certain spot. The issue is you have 15, 16 pieces of gear that all have different depths. So what happens is, if I use just a straight bar, I don't want to have multiple sets of rail just for my straight bar. So with an offset, you can either go 2-inch, 4-inch one way, 2-inch, 4-inch, up to 10-inch, either direction. So you can have one set of rear rail. Basically, it allows you to use different offset lacer bars. Again, you want to label. That follows some of the standards that are out there. All cable must be labeled. And then the other thing with this is keeping it close to the connection. Getting that cable nice and tight over there so it doesn't put pressure onto your connector in the back. So again, organizes, leaves room for the labeling like we talked about. And it's a way to also dress from left to right too. A lot of times you may have come up the left side of the rack and need to get over to the right. It's a great way to do it. It's go horizontally across and then come up to the equipment. So a couple quick tips. One of the things we're talking about was the rear rail. Racks are getting deeper. So sometimes you may have that room in the back of the equipment for cabling, but you may not have the room on the sides. So what this is 3 different offset lacer bars on the same, basically right one underneath each other. And it gave me, you're looking down at it, so basically it gives you 3 planes of cabling from front to rear instead of trying to go on the side if you don't have the room. And there's some round lacer bars just showing it as a nice way to dress cables in the back here. The other thing is you'll find a lot of times cabling goes in here between, say, your equipment and your rack rail. The thing is, when you do rack screws, most rack screws are over, you know, 1 inch or so. So what happens is you get it's sticking up, so you don't want your cables in here. There's little short screws that have a round head on them, so you can use that for lacer bars and stuff on your rear rail. It allows you to keep your cable in and not having to worry about rack screws screwing into your cable. So it's a couple of things that I've seen and figured I'd just shoot them out to you guys. And then standards. I mean, here's some of the bigger standards that you guys may see. There's a ton of different standards out there. Again, it's ANSI TIA. So some of the commercial building, residential, and things like that. But these are the 3 that you probably come across the most in the AV. So just wants to know that are out there, and good stuff to know, and tells you all the things that you need to be aware of. Any questions on cable management before I jump into thermal? Or okay. So a couple takeaways for thermal management. Basically, we have, you know, maintaining the proper equipment temperature. We're going to talk a little bit about that. 85 degrees is operating temperature inside a rack. That's what you want to hit. A system you want to look at, you know, you want your fans to work with. Some of your equipment may have fans, so you want You want to be able to make sure that everything's good with that. And then the functionality of the equipment, knowing how it breathes. So there was a study done, it says that for every 10 degrees above 85 degrees, some of the digital equipment loses 40% of its life. So do the math. If you saw a rack that's getting 25, 30% hotter, that gear's not going to last very long. So just something to be aware of with how important thermal management is. Basically, here's some of the stuff that we're going to talk about. Know what's required. You want to plan for your airflow, as well as planning based on the location where the rack's going to be. And then future planning. Again, thermal, you talk a lot about planning. You want to think about it ahead of time so that you're not worrying about it later on when everything's getting hot in the rack and you have to go back out and figure out what's going on. So knowing what's required. So one of the things you want to remember, the main objective about thermal management, you want to get the heat out of the rack. It's much easier to let a rack do what it naturally does, let the heat rise and come out. You want to help that by with maybe some fans or something like that, but you want to get the heat out. A lot of guys will say, well, let me just take air conditioning, pump it into the rack. Well, you still got to get that heat out of it. So the best thing is to remember just to get the heat out. That's your first thing you want to do. So I'm going to show you a little bit how to kind of figure out what kind of cooling you're going to need. We're going to go through a little thing how to calculate BTU. Basically, a lot of the amplifier and stuff, you're going to look at the nameplate. It'll tell you. There's a formula that you're going to need to know. Once you get up to your BTU, so total measurement, your amperage draw, here's your formula. By 400, so come up with my BTU. And you'll see what it makes a little bit more sense in the next slide here. Now that I got my BTU, what we're going to do is we got a thing called Nomogram. Basically, I say I'm going to have 4,000 BTU. Now I'm going to figure out what my room temperature is. So with my room temperature at 70, and I got a line to the 4,000, just do a straight line. And we actually, there's thermal calculators that are out there. You can do this as well. As you can see, this is a nice little spot to be in right here, because it's kind of where active and passive kind of overlap. And what we say is always try to go with a passive versus an active. If you can get away with a passive cooling, there's less that can go wrong, less energy is being used. It's just going to let nature take its course and do it, and do the cooling instead of counting on an active fan or something where you could have noise, you could have the fan go bad or something like that. So with here, we would definitely go with a passive system. Just by going up a couple of degrees, you can see at that same BTU with that same different room temperature, you can see now my CFM that's being used is going up. And just another 2 more degrees. So it does make a difference, then a couple of degrees in that room that you're doing. So planning the airflow, again, you're going to look at the equipment that's used. Currently today, you're probably going to see a lot of stuff that pulls cool air from the front and blows it out the back. It could be pulling it out through the front and blowing it out the sides. There's some equipment out there that does that. So you just got to be aware of it and knowing how you're going to handle the rack inside. If you got a bay of racks, one of the things you want to be concerned about, you don't want that hot air blowing into the next rack. So you want to kind of block that. So some of the bigger switches do that, and there was a couple amplifiers that did that as well. It's got the fans on the side, so it blows it out one side. So you may have equipment in another rack. You want to make sure you're not overcooking that equipment there. So by doing something in the middle to block the racks. So again, the most common is front to rear is what we're seeing today. And basically what you want to make sure is you don't create any hot spots. And what a hot spot is when the hot air gets caught within inside the rack, because it may have cool air where it can't get through. And what that'll do is you'll see it in a couple of slides with a little graph showing it. So we'll move on to that. So like I said, passive, way to do it. If you can get away with it, again, just works much better. So there's the wrong way to do it. So as you can see, what's happening here is there's vent panels between. This equipment has fans in the front, or it's pulling the air in. What happens is it short circuits. So basically it's just a fan's gonna pull from the easiest place that can get air. So right now what it's doing is it's just short-circuiting, and none of the cool air is going to be able to get in. So with this, we just basically took them same units, closed the gaps, or you can put a blank panel in between. And basically had the opening at the bottom and the back here, so air, same as over here, but what it's allowing the air to do is just convectively just go out the top. And so you're vented at the top, the front, and even in the back. So as the hot air rises, it finds its way out. But you just don't want to cause that, the blockage there. So now we get into planning. So there are a lot of times you will have to use an active cooling system. So one of the things this is what we call a hotspot, or this basically could happen if I got a vent at the top and I got a fan here. What we talked about is that fan's only going to pull air from the easiest place. So what it's doing is it's pulling cool air from right here. So you see a lot of the racks that are out on the marketplace, they actually have vents at the top because they're designed for convection. And then when you go to put a fan top on it, you want to make sure that you block that top vent off, because that right now you're just causing cool air to circulate up here, and the hot air can't get through that. So basically the hot air is staying within the rack. So the proper way is you kind of block the vents off over here, top third of the rack or so you can start that hot air with the fan. It'll pull the hot air right out, and basically gives you a nice chimney effect outside the rack. And then some of the other stuff is your room. You could be going into a control room, you could be going into a hot environment. So again, knowing what that ambient temperature of the room is going to be is pretty important before you get to the job, knowing what's going on. This is a typical, like when we say control, it could be a server room. So you're not seeing this much anymore. However, it's still out there where the cool air is actually being pumped underneath and going up into the front of the rack. A lot of times you'll see this though. You got a hot aisle, cold aisle. Both your rear of the racks are pointing hot air here. Usually have an exhaust over here. And then your cold is here because all your gear is pulling from the front. So if your racks are front to front, so you got a nice cold aisle and then another hot aisle here. So you'll see that on some of the bigger rooms that are controlled by air. And one of the things that we're seeing happening these days now is aisle containment. What they're doing is, instead of trying to do the whole room, what they're doing is, so in something like this, if it was just one big room, you have all this cold air here pulling these racks, and the same room you're throwing all the hot air into. So what you do is you contain the cold, so you're only sending cold air to the certain aisles and not trying to keep the whole room cold. Or you can do it vice versa, where you have the hot air coming out, you contain the hot air and get it out and keep the rest of the room cool. So you're not trying to do a full room, you're only trying to half a room. And then basically, again, we talked about future planning, the design of the racks, the thermal load. You want to know what that is, the type of room that it is. Blank panels are always good to have around. Again, if you think you're going to have some empty rack spaces for some future stuff, put a blank panel in there. You want to keep that air from not coming in and out of there. And I think I blew through this a little quick, so hopefully you guys have had any questions or anything, and if I didn't miss anything, or sure.
You mentioned there was a study about the
heat.
The heat.
Yeah.
If we're called to task on that, where can we get that?
Can you repeat that for the web?
So, yeah. And where you want to find out where you can get the study?
Yeah.
Okay. So there's a set on here we're talking about that any 10 degrees over 85 degrees, there's a 40% life. I believe that was done by, I have to go back and find, I think it was a Claro that had done some study on that. What was it? Uptime Institute, yeah. And I think we have it actually on a white paper, and I can get you the information of where that study is. Any other questions?
What about just managing heat in credenzas?
So one of the things you want to do, you want to not have the heat come out. A lot of times the credenza is up against the wall.
Yeah.
So depending on the credenzas that you're using, some of them are built to have cooling in them. other ones where you have, you could look for a smaller fan that can do on the side, blow the heat out the side. Problem, like I said, the best way to do it is bring some cool air in through the front and out the back, but a lot of times it's up against the wall.
Right.
And you don't want to bring it up and through, and so usually what you'll do is do some kind of cooling on the sides,
Right.
side of it, because your back, you just don't have the room for it. So, again. Any other questions? Think we're good? Oh, okay, got one.
Yeah, you used a number of 400 for calculating your BTUs. Is that changed since using the 3.41?
I'd have to check on that. I do not believe it has changed. It should be the same.
Okay, because I always used to use the wattage times 3.41
Right.
to come up with the BTUs.
Okay.
I just thought that was different.
So the question was the 400 still accurate, or was it the 3.41? And we will take a look at that, but I believe the 400 is still accurate. Okay. Well, thanks everyone. Appreciate it.